Hello students, we were doing three dimensional geometry, line and plane के questions कर रहे थे हम. Line and plane के अंदर topic था angle between line and plane. 4 तक questions किए थे हमने. Now the next question number 5. Find the vector equation of line passing through the point with position vector. पास कर रही है point से 2i minus 3j minus 5k and perpendicular to the plane r dot 6i minus 3j plus 5k plus 2 is equals to 0. We can write it as equals to minus 2. Equation of plane is r dot n vector is equals to d and the vector equation of line is r vector is equals to a vector plus lambda b vector. A vector through point through which the line is passing and b vector that is parallel to the line. Now we have given the line is passing through this vector a vector. It is given and it is perpendicular to the plane. Now if line is perpendicular to the plane, that means it is parallel to its normal, that is line is parallel to the normal of plane. Normal of plane means n vector. What is the value of n vector? 6i minus 3j plus 5k. It means the required equation क्या होगी? Which passes through a vector and parallel to the n vector. So vector equation will be a plus lambda n vector because line is parallel to the normal of the plane. A vector is 2i minus 3j minus 5k plus lambda into 6i minus 3j plus 5k. So this is the required vector equation of the line. Now the next one, find the equation of line passing through 3, 0, 1 and parallel to the planes x plus 2y equals to 0 and 3y minus z equals to 0. Now we want to find the equation of line which passes through this point and parallel to these planes. Let direction ratios of required line are proportional to A, B and C. Now equation of line which passes through this point x1, y1, z1 and whose direction ratios are A, B and C is x minus x1 upon A, y minus y1 upon b, z minus z1 upon c. Now we do not have the value of ABC. We want to find the value of ABC to find the equation of line. Now it is given that line is parallel to these planes. If line is parallel to these planes, it means it is perpendicular to their direction ratios. So what will be the equation? A into 1 plus 2 into b, 0 into c because z component is not here. And for this equation, a into 0, x component is not there, 3b minus 1 into c. Clear? Because line is parallel to these planes, therefore, ये हमारे पास equations आ गई. इसे हम क्रॉस मल्टीप्लिकेशन से सॉल्व करेंगे to find the value of A, B and C. Let this equation as equation number 1. Now A minus 2 minus 0, B is 0 minus minus plus 1 and C is 3 minus 0. So we get, let this equals to lambda. So what we get? A is equals minus 2 lambda, B is equals to lambda, and C is equals to 3 lambda. Put these values of A, B, C in 1. Put these values in equation 1. So what we get? X minus 3 upon minus 2 lambda, Y minus 0 upon lambda, and Z minus 1 upon 3 lambda. Eliminate lambda. X minus 3 upon minus 2, Y minus 0 upon 1, Z minus 1 upon 3. So this is the required equation of the line. Note it down. Next one, find the equation of plane passing through the line of intersection of the planes 2x plus y minus z is equals to 3, 5x minus 3y plus 4z plus 9 equals to 0, and parallel to the line x minus 1 upon 2, y minus 3 upon 4, z minus 5 upon 5. Now the equation of plane passing through intersection of these planes. Equation of plane passing through intersection of given planes. क्या होगी? This plane, equation of this plane plus lambda into equation of other plane. Now it becomes, taking x common, 2 plus 5 lambda, y common, 1 minus 3 lambda, z common, minus 1 plus 4 lambda is equals minus 3 plus 9 lambda equals to 0. Clear? Now it is given that the equation of plane passing through intersection of the given planes is parallel to this line. Parallel to this line means its direction ratios are proportional. Direction ratios are perpendicular, a1 a2 plus b perpendicular to its normal. Therefore a1 a2 plus b1 b2 plus c1 c2 equals to 0. तो क्या हमारे पास इक्वेशन आई? A is 2, so 2 into 2 plus 5 lambda, 4 into 1 minus 3 lambda, 5 into 4 lambda minus 1 equals to 0. The plane 1 is parallel to given line. Therefore हमारे पास ये आया a1 a2 plus b1 b2 plus c1 c2 equals to 0. Solve it. 5 into 2, 4 into 3, 5 into 4 and 5 into 1. 18 lambda plus 3 equals to 0. So we get the value of lambda as minus 1 upon 6. Put this value of lambda in equation 1. X into 2 minus 5 by 6. Y into 1 minus minus plus 3 by 6. Z into minus 1 minus 4 by 6. Minus 3 minus 9 by 6 equals to 0. 6 into 2, 12 minus 5, 7. 6 plus 3, 9y upon 6. Minus 6 minus 4 minus 10 by 6z. Minus 18 and 9 minus 27 by 6. So we get the equation as 7x plus 9y minus 10z minus 27 is equals to 0. So this is the required equation of the plane. The next one. Find the equation of plane passing through intersection of planes R dot I plus j plus k is equals to 1, R dot 2i plus 3j minus k plus 4 equals to 0 and parallel to the x-axis. Now equation of plane passing through intersection of given planes. Passing through intersection of given planes. If given planes are r dot n1 is equals to d1, r dot n2 is equals to d2, then equation of plane passing through intersection of these is r dot n1 vector plus lambda n2 vector is equals to d1 plus lambda d2. Use this formula here. R dot n1 I plus j plus k plus lambda n2 2i plus 3j minus k is equals to d1 when it goes on the right hand side minus 4 lambda. So what we get? R vector dot 1 plus 2 lambda I cap 1 plus 3 lambda j cap 1 minus lambda k cap is equals to 1 minus 4 lambda. Now it is given that it is parallel to x-axis. It means its dot product with I cap is equals to 0 because it is in vector form. 1 plus 3 lambda j cap give reason because plane 1 is parallel to x-axis, therefore हमारे पास ये condition आई. Clear? Now solve it. 1 plus 2 lambda I dot I is 1, I dot j and I dot k, that will be 0. From here we get the value of lambda as minus 1 by 2. Put this value of lambda in equation 1. Put value of lambda in 1. R vector dot 1 2 into minus 1 by 2. Minus 2 by 2 I cap 1 minus 3 by 2 j cap 1 minus minus plus 1 by 2 k cap is equals to 1 minus minus plus 4 by 2. So what we get? R dot 0i 2 minus 3 minus 1 by 2j 2 plus 1 3 by 2k is equals to 1 plus 2, that is 3. Now take 1 by 2 common. So what we get? R dot 0i minus j plus 3k. 2 goes on the right hand side. 2 into 3, 6. This is the required equation for the plane. Next one, find the equation of plane through the point 1, 0, minus 1, 3, 2, 2 and parallel to line x minus 1 upon 1, y minus 1 upon minus 2, z minus 2 by 3. Now equation of plane passing through 1, 0, minus 1. Equation of plane passing through one point. x1, y1, z1 is a into x minus x1, b into y minus y1, c into z minus z1 equals to 0. This is the equation of plane. Now, equation of plane also passes through Z2. So what we get? 3 minus 1, 2a plus 2b plus 3c equals to 0. Now it is given that the equation of plane, that is first equation, is parallel to the line this. Now plane 1 is parallel to line. Therefore A1, A2, its direction ratios are 1, minus 2, 3. 1 into A, minus 2 into B, 3 into C. Solve equation 2 and 3 by using cross multiplication to find the value of ABC. A is 3 into 2, 6, minus minus plus 6. B is 3 into 1, minus 3 into 2. C, minus 2, minus 2, minus 4, minus 2. So what we get? A upon 12, B upon minus 3, C upon minus 6. Or we can write it as cancel by 3, 3 into 4, 3 into 1 and 3 into 2 equals to lambda say. So A is 4 lambda, B is minus lambda, C is minus 2 lambda. Put these values in 1. What we get? 4 lambda into x minus 1 minus lambda into y minus 0 minus 2 lambda into z plus 1. Taking lambda common and eliminate it, we have left with 4 into x minus 1, 1 into y minus 0, z minus 2 into z plus 1. Now open the brackets. 4x minus 4 minus y minus 2z minus 2. 4x minus y minus 2z minus 6 is equals to 0 is the required equation for the plane. Note it down. Now next one is state when the line r vector is equals to a vector plus lambda b is parallel to the plane r dot n vector is equals to d. Show that the line r vector is equals to I plus j plus lambda 2i plus j plus 4k is parallel to plane r dot minus 2i plus k is equals to 5. Find the distance between the line and the plane. Now we know that if the line is parallel to the planes, it means it is perpendicular to its normal, that is b dot n is equals to 0. Write down. If the line is parallel to the plane, if the line is parallel to the plane, कब line parallel होगी plane के? It means normal to the plane is perpendicular to line, that is b dot n is 0, or we can say that b vector is perpendicular to n vector. Now अगर हम इसमें ये शो कर देते हैं कि b dot n is 0, b vector is this is a vector and this is n vector. Find the value of b dot n. 2i plus j plus 4k minus 2i plus k. 2 into 2 minus 4, j component is not there, 4 into 1. B dot n is 0, it means b vector is perpendicular to n vector. It means the line is parallel to the given plane. This line is parallel to the given plane. First हमने proof कर दिया कि अगर ये line इसके parallel है तो given line उस plane के parallel होगी. Next condition is we want to find the distance between between the line and plane. What is the formula to find the distance between line and plane is A vector dot n minus d upon magnitude of n. यही है हमारे पास to find the distance. Now A dot n. A vector dot n vector. A vector is I plus j dot minus 2i plus k. I dot I minus 2, j and k component is not there. So A dot n has value minus 2 and d has value 5. Now magnitude of n vector minus 2 square plus 0 square plus 1 square. 4 plus 0 plus 1 square root of 5. 5 minus 2 is 3 upon square root of 5. So distance between the given line and